Imagine a place where snow decides whether this whole region is connected to the world or it just disappears from the rest of the world. Every winter, as snow begins to fall, this road slowly vanishes under layers of ice, sometimes buried under 20 to 30 feet of snow. Temperature here just don't drop, it just crashes below to minus 25 degrees centigrade. Engine fails, oxygen level falls, and one small mistake on these narrow winding edges can send you straight into 1,000 foot drop. This isn't just a road, it's a gamble between life and death. Yes, you will say it a gamble because even a mistake can lead you to death. This isn't just road. For decades it's been a gamble between life and death. Ambulance couldn't pass, supplies couldn't reach, families were cut off, completely isolated from the rest of the country. And you might be thinking by now or wondering by now that what is this place? This the Atal Tunnel. I am talking about the Atal Tunnel. A tunnel that didn't just cut through mountains, it just defeated them. Hey guys, I am Ashutosh Kumar and welcome you back to my channel. Here we explore mind-blowing engineering projects and stories behind them. So I know you might be wondering that how we just created or carved a tunnel within the unpredictable or dangerous mountains of not just India but of world, you can say. Building Atal Tunnel wasn't just engineering, it was a survival. The first challenge while building Atal Tunnel was obviously the extreme weather. This wasn't just cold, this was kind of cold that shuts everything down. Temperature here didn't simply fall, they plugged below minus 25 degrees centigrade. Where machine stops responding, diesel freezes, and even metal begins to turn brittle. Yes, metals become so much brittle, like so much hard that every metal becomes like a knife, you can say. Workers couldn't stay outside for a long, their hands would go numb within minutes. Breathing itself felt heavy in thin and icy airs. You can just say like you are just having your Maggie, you pull it out from your spoon and it just froze. You just can't eat that Maggie now. Construction in this region didn't just slow down. At times it felt almost impossible for our engineers to complete this project. Engineers in India are great, they just rethink everything, and heated shelters were set up inside the tunnel, work was broken into short and controlled shift, and special equipment was used so that workers would survive in these brutal conditions. Here it wasn't about building a tunnel, it was about finding a way to work in a place where nature clearly didn't want you to. Right, matlab nature didn't just want you to go to work, nature doesn't want you to go or meet to your family, and if something happens crucial, and if something happens to you or your family, you just can't go to the nearest hospital because it's so much frozen, you have to climb the whole mountain. This wasn't right for Indians residing there. So it was very important to build this tunnel at this point of time now. The second challenge was the unstable Himalayan geology. On paper, you expect mountain to be solid, strong and unbreakable. But here, the Himalayas behaved more like a crumbling puzzle. In my first video, I have just told you all that Himalayan ranges are young, some ranges are strong, some are weak, and because of this unpredictable layer, construction in Himalayan range is like very difficult. So as soon as engineers started digging, the rock didn't hold its shape. It cracked, collapsed, and in many sections, water started gushing in unexpectedly, turning parts of the tunnel into muddy and dangerous zone. At any moment, the roof could cave in. One wrong move and mouth of work could be buried within second. This wasn't construction anymore. This was a constant uncertainty. But yes, engineers built it. You know what they used? Engineers used the new Austrian tunneling method. Instead of forcing the mountains to behave, engineers decided to listen to it. Yeah, you might be thinking that how a person can listen to a mountain, but let me break down. New Austrian tunneling method works on a simple principle, but it's a very powerful principle, I would say. The mountain itself became the part of a support system. As they dug forward, they didn't just blindly continue. They observed how the rock recreated, where it cracked, where it shifted, where water entered, and then immediately changed their approach. If the rock was weak, they started shotcrete, sprayed concrete instantly. If pressure increased, they installed rock bolts and steel ribs for support. If water seepage appeared, they created drainage system on the spot. Every every few meter, the design could change. There was no fixed plan, only constant adaptation. And this adaptation just helped us a lot. Because in a mountain like Himalayas, you don't control nature. You negotiate with it every step. And step by step, you start negotiating. You just start building your tunnel step by step. And yes, the third challenge, low oxygen at high altitude. At over 10,000 feet above sea level, the air present here isn't just cold, it's thin. Every breath carries less oxygen than your body actually needs. For the workers, every simple task like walking or lifting tools felt exhausting. Within minutes, they could feel dizzy, breathlessness, their heart racing up just to keep up. Some suffered to severe headache, nausea, and fatigue, classic signs of altitude sickness, and in extreme cases, it could turn deadly. Now imagine doing heavy construction work in this condition day after day inside a tunnel with limited fresh airflow. And this wasn't just uncomfortable, it was a constant risk to our life, to those life who were building the tunnel for those residing in that pass. And the solution this problem was like very simple. Engineers treated this like a medical emergency, not just a work condition. Workers were given proper assimilation time before starting shifts. Oxygen support system were installed inside the tunnel itself. Dedicated medical team, emergency setups were always on standby. Work hours were carefully controlled to prevent over excretion. Because here the challenge wasn't just building through the mountain, it was making sure the people building it could actually survive the process. And finally, avalanches and landslides. This was the kind of danger you couldn't predict and couldn't escape also. Means you pass through and that landslide is just coming over you and you just can't stop it. Massive slab of snow and ice could break at any moment, rushing down mountains with unstoppable force. Within seconds, entire axis of road would disappear, machinery buried, progress wiped out. And it wasn't the snow. Loose rock and unstable slope meant landslide could strike without warning, turning a normal workday into a life-threatening situation. There were times when teams had to stop everything and evacuate, just waiting, hoping mountain wouldn't come crashing down again. One avalanche was enough to undo months of effort. One landslides and life would be at risk. And solution to this problem, engineers thought beyond construction. They had to think about survival now. Real-time monitoring systems were installed to detect early signs of avalanches. Protective galleries and barriers were built to shield the road and workers. Work was planned around weather patterns and risk zone, not just deadlines. Emergency protocols ensured rapid evacuation whenever dangers increased. Because here you don't get a second chance. If you just trapped, you are just trapped onto it. This wasn't just construction, it was a constant standoff with nature, where every single day mountain decide whether you could continue or not. Now you might be thinking that Let's suppose Atal Tunnel is built, engineers took so much difficulties, faced so much problems, they even faced medical emergencies on a regular basis. What's the importance of this Atal Tunnel? So let me break down in some points and tell you that how much benefit Atal Tunnel gave to the residents of those residing near Rohtang Pass. First problem that existed for decades solved in just minutes. You now don't need to climb a mountain for a rest of 6 months. You just need to take that a 9 kilometer of pass and whoop, you are into a new city now. It was once 5 to 6 hours risky, unpredictable tower, and it is smooth 10 minutes journey through the heart of mountain and you are into a new city. For people of Lahaul-Spiti, this isn't just convenience, it's lifetime resorted. No more month of isolation, no more waiting for roads to reopen. Now even in the harshest, you can say the most hard condition. Now, even in the most harsh condition of winters, life keeps moving. Hospitals, supplies, opportunities all within reach now. And yes, it's too much beneficial for Indian arms too. This tunnel is more than infrastructure, it's a strategic strength. Faster movement, better logistic, a stronger, more prepared nation at its border. And beyond all this, the region is opened up to world. Tourism is rising now, local businesses are growing, faster movement, better logistics, and the region has opened to the world. Tourism is rising, local businesses are growing, and entire economy is breathing again. It's an economic boom to that region. This isn't just a tunnel. It's what happens when vision, engineering, determination come together to solve a problem that once seemed impossible. And as an engineer and as an Indian, this is something to be truly proud of. And to thank engineers, contractors, workers, and to the medical personals too, who helped us a lot. They were the key component of us because the place where everyone is just getting ill normally means you can get severe headache, you can't breathe proper air here. So medical personals helped us a lot. And here's what I want to say. It's not about medical versus engineer, it's about combining both and to making something which is for greater good. And at last I would just like to say that it's not a war that engineering is good or medical is good. I just want to say we both require at certain points, and we both are built, or we both make ourselves in such a way that we have to crack greater things in life, right? So if stories like this where engineers meet human determination interests you, there's a lot more waiting to be explored. Signing off for today until we meet again with another remarkable engineering marvel. Tada, bye.